Even I have been surprised by how on fire everybody is for single root I/O virtualization with Intel GPUs. It's popular now because of the B50 and the B60, but we need to revisit. We need to revisit the Flex 140 and the Flex 170. Thanks to a kind soul that sent me a Flex 140. I did not previously have a Flex 140. We have updated the guide on the forum for Proxmox 9 because it was a little bit of a rabbit hole wrapped in an enigma and like a taco salad. Let's discuss, and you can learn a little bit more about my process as well. So I don't know. Let's take a look at what it takes to run SR-IOV on Proxmox with a modern 6.14.8 kernel. All right. So the promise here, if you've been out of the loop, is that this passively cooled GPU. Now, passively cooled in a server context means that there's a crazy amount of airflow running through this. Don't buy one of these for a desktop computer or a desktop Linux machine because it will overheat unless air is being forced through this very long heat sink. It's fanless, but it's not really passive. This is a Flex 140 GPU. There's actually two GPU chips on this, and this is designed to support, 4 to 22-ish virtual desktop sessions. Basically, you get graphics acceleration for virtual desktops. Now, the last time we did this, we're using our Supermicro 111E. We are still using that. That has actually been running continuously, testing various workloads and doing various things. It's only just in the last week or so that I upgraded it to Proxmox 9, however. Things got real dicey around kernel version 1.8. Let me give you some background. Intel has been going through a little bit of a rough patch. And that also includes the driver team. And a lot of the driver team that I knew that was really advocating for SR-IOV, they aren't at Intel anymore. And I had a meeting with an executive like 2 years ago, and I said, if you build it, please just do this. You've already done all the plumbing for Red Hat. Please just do this. It'll be amazing, I promise. And I like that I've been mostly validated by that. Intel has updated their documentation for their part. On their website, they have Ubuntu SLES, SUSE Linux Enterprise Edition, as well as Red Hat. And I leaned on that a little bit for doing our setup guide here. They also have their own i915 DKMS backports out of tree. They're doing backports correctly. If you haven't heard of backports before, that is like the standard Linux way of putting new drivers into an old kernel, standard-ish, and they've mostly followed the rules. There's a couple of landmines you can trip over, and there's a couple things that I'll show you in Proxmox, but by and large, Intel's been doing the right thing here. They also have a firmware repository, which makes it easy to get the firmware on your distro, and we're going a little outside the lines with Proxmox again, and they've made it pretty easy. With the exception of card firmware, you have to, please, anybody at Intel, if you're watching, go ahead and put the card firmware in with the other firmware on the Git repository, please. The driver doesn't have to do anything with it. We can just quietly slip the current versions of the card firmware in there and still leave it up to the user to update that. You have to use the XPU SMI utility to update the firmware. We'll talk more about that. But Flex 140 and Flex 170 are data center GPUs, and right now, today, the best driver is the out-of-tree driver, and with all of the happenings inside Intel, probably, maybe, possibly, the functionality for this will be merged in the XE driver. So everything that I'm talking about here doesn't really have anything to do with Intel XE and the SR-IOV that is happening on XE, in-kernel drivers for newer versions of the Linux kernel, like 6.14 and newer. I say mostly. Eventually, someday, that might be true. So if you're watching one of the older videos that are now really out of date, this video might be out of date in the same way. I've sort of been waiting for XE to come along. Up until now, we had been relying on the strong TZ out of tree 915 patch, and there's a lot of folks over there doing Herculean stuff to get SR-IOV to work in the context of an iGPU. People running Plex Media Server at home with virtual machines and containerization pass-through want to be able to pass those hardware transcoders to a virtual machine or a container that's running Plex, and that is a perfectly reasonable and valid use case. We were sort of the people watching this video and me, were sort of riding the coattails of the awesome work over there in the first Flex video that I did, and that worked fine because the drivers and the plumbing happened to be there. That has ceased to be the case as of late 2024. And part of that was because kernel 6.8 really started changing everything, and no one really felt compelled to do the work to close the loop on getting the Intel i915 stuff as it relates to Flex Data Centers GPUs working on kernel 6.8. So I revisited that a little bit. If you need to get this working on kernel 6, hit us up in the forum at Level 1 Techs, because I'd love to hear. But mostly, you don't need kernel 6.8. You need a newer kernel than that. But the DKMS driver does actually work with kernels older than 6.8 as well. So we're in this weird state where if you install the DKMS drivers and you have like kernel 6.1 or 6.5, it'll build fine, but then 6.8 breaks everything, but then it starts working again on 6.14. This is because there's stuff inside the DKMS that's like, do this thing if you got an old kernel, do this thing if you got a new kernel. Intel actually has a really nice driver table that is impossible to find by search engine. That is linked in the guide for you to look at that, and that gives you an idea. It's like, okay, is this a kernel driver? Which kernel version do I need? Is this an XE? Is this out of tree? Out of tree means the DKMS i915 driver that I'm working on here. Now, this seems like a lot of exposition, but I'm trying to arm you with the mental framework to understand what you're looking at when you search and you find all the different GitHub repositories and all of the stuff that has led up till now. It's like the work's going on over here, the work's going on over here, the work's going on over here. And mostly that was happening while Intel was also doing a lot of work. And so for 2025, the Intel driver people, the people that are left, have been doing Herculean things and moving mountains from the looks of it. And things are in a much, much better shape in October of 2025 than they have been in a long time. So let me walk you through the guide and getting set up with, bearing in mind that we're going to be using Proxmox 9 and we're going to be using kernel version 6.14.8. Now, I know there's another newer kernel than 6.14 in this series, but 6.14.8 is the first one. And depending on the firmware version and the Intel driver version, certain kernel versions are more stable than others. You can also run into instability with IOMMU groups on your host machine. And this Supermicro pizza box platform, to deploy a half a dozen of those for, an army of 50 office workers, that is a great, solid solution. And Proxmox can actually move the VMs and manage high availability and ZFS replication between those hosts. You can also use iSCSI. I'm using iSCSI off of a Synology, the dual port Synology that we reviewed previously with SAS SSDs as the boot volume. Over 25 gigabit iSCSI has worked out fantastically for testing and everything else. This is our Supermicro SYS 111E, and I've added a Flex 140 to the layout here. Now, there's actually room for I can put another Flex 140 or a Flex 170. This chassis will actually fit 3 GPUs. I can also have redundant storage here, or I can just use my iSCSI volume. But this is a great little AMD-based Zen 3 pizza box. It has 256 gigabytes of memory, and this is a great building block for a VDI solution. I would deploy these like 5, 7, 12 at a time, and this would really handle a lot of office workers at once. And definitely thanks to Supermicro for letting me borrow the system for so long so that I can keep the software updated and working on it. For now, I've left the old information in the guide, but doing it the new way is actually a lot easier. There's a lot fewer steps, and I will probably remove this or hide this in an old revision. You can always use the little pencil icon. I think if you've got an account and the trust level is high enough, you can use the pencil icon to get to the old versions. But if you skip down to the bottom, there's a couple things you'll refer to in the old guide GUI setup, but mostly the walkthrough is at the bottom. At a high level, what we're going to do is get the stuff that we need from Intel, which is trusting the Intel key and setting up some packages and setting up the XPU SMI utility. This is like the NVIDIA SMI or the AMD SMI utility that lets you do stuff with the card. That utility lets you query one or more cards that are installed in a system. It lets you update the firmware. It lets you create virtual GPU instances. You can echo stuff into the SR-IOV num functions thing in sys, but the utility is a little easier, and that's all well and good. Also, we'll walk you through setting up Proxmox because there's a bug in the Proxmox GUI. This has 2 PCIe devices on it, which means it has a PCIe bridge. This is a long-standing bug in Proxmox, and I think it goes back to Proxmox 6. When you have devices behind a PCIe bridge and you try to bind them, VFIO will not do that. And that is because the script that tries to figure out what the device ID is the thing that needs to be bound doesn't look deep enough down the tree. It ends up trying to bind it to the thing that's the root complex for the downstream bridge or something like that. And that's not cool. It's not cool. So there's a systemd service and a helper script that I created to help you in this situation. And the helper script, I probably need to adopt that to the B50 and the B60 because we're starting to get people that are like, hey, this doesn't survive a reboot. Yeah, sorry about that. My bad. You're going to need a similar helper script for the B50 and the B60. Anywho, when you got all the dependencies, you are probably going to also have to build the Debian package for i915 DKMS. And we're going to lie to Intel's build script and tell it that it's Ubuntu 24.04 using its codename. Because Proxmox's codename shows up as Trixie, which is not supported. But Intel's build script and the URLs that it uses for its deb repository is has the Ubuntu names baked in. But it works fine. It works fine on this kernel on Proxmox. It's totally okay. It's not a problem at all. So here's one of the things that is also driving this is like the strong TZ repository, which used to have this functionality. There's a GitHub issue. You can check that out, but they don't really want to support Flex. If somebody wants to do more deliberate maintenance on Flex, do you just need remote access to a Flex system to do your CI/CD thing? Hit me up in the forum. I don't want to be the guy that's responsible for that. I got too much other stuff going on, but I can babysit hardware for you with the best of them. It doesn't look like that's going to be necessary with the work that Intel is doing, but it's still going to need probably some randos like me to dot the I's and cross the T's, especially when we go off script with the kernel version versus what Intel's team expects. And I don't think we should necessarily expect Intel's team to be responsible for all versions of the kernel since time immemorial, but I digress. And the first thing in the guide is updating the command line parameters for your kernel. If you don't know how to do that, there's other guides for that on the forum. You can also just ask ChatGPT or Claude at this point. But you're going to edit, because this is the Grub bootloader, you're going to edit etc default Grub. And you're going to turn Intel IOMMU on and turn IOMMU explicitly to PT. And I have this legacy option, i915.enable_GUC=3. I don't even think this is necessary anymore, but this was on the working system, and so that's what we're going to roll with. There's other things that are deprecated, like number of virtual functions, and there's also different versions of the i915 driver. Again, if you're not familiar with like backports and how that works, the 915 driver is actually built into the kernel, but the 915 driver that we're getting from backports that we're going to build ourselves that comes from somewhere else is like the size of a Buick. And the one that is built into the kernel is like a two-wheel moped. And all the SR-IOV functionality and all the stuff in the kernel version of the i915 driver is not really appropriate for us. We need the land boat-sized version of the i915 with all of the accoutrement that comes with that. And sometimes the kernel gets confused. And like DKMS is supposed to say, okay, we're not going to use the i915 driver that's in kernel. We're going to use the land boat version. It doesn't always get that right because guide. We're also going to add a configuration file, i915.conf in etc under modprobe.d. And we're going to add an option here, which is force probe of 56C1 and 56C0. These are the PCIe IDs of a Flex 170 and a Flex 140. So this is both. I'm doing my testing and my integration with a system that has both a Flex 140 and a Flex 170. And remember that a Flex 140, each Flex 140 shows up as 2 devices. So if you have 2 of those in a system, it'll show up as 4 devices. And things can get a little weird with the Intel utilities with that, because when you're doing updates or running driver versions or whatever, the firmware version matching and all that stuff needs to be a thing. We'll talk about that in a second. But basically, it's okay. We're also going to blacklist the XE driver because we don't want the XE driver to try to load and attach to that. If you use LSPCI and look at the capabilities of the card, it will say, oh, I can load the XE drivers with these GPUs. You don't want to do that. Not yet, anyway. Someday that might be amazing. Are you on the Intel team? Is it ready? Let me know. Reach out. Would love that. Thank you. You also want to apt install Proxmox headers 6.14.8-2-PVE and 6.14.8-2 the kernel and the headers, basically. Now, the numbers at the end can change a little bit, but 6.14.8 is the important part here. 6.14.11, for example, it's not working for mysterious reasons. I may have that fixed. Don't trust the video. Go to the guide, follow the forum. This is just like a walkthrough to make you a little more comfortable. All right, so the next step is getting the Intel driver that you can backport. Now, if you want to try to apt install Intel-i915-DKMS, Intel does have that in the repository that we added in the previous step. And you can see if that works. You'll need to reboot. It'll rebuild the initial RAM disk. You'll get some output. That might work. And if that works, then you can skip the backport driver adventure. It did not work for me. So for the Intel backport driver adventure, what we're doing is cloning a repository from Intel that has the driver. And so but we're also going to install things like the firmware and the XTU utility so that we can update the card. And so you want to install the key, and if you don't have wget and GNU PG, you'll need that. You want to make sure that you've created the source file so that you can grab the packages, and then you want to do an apt update to make sure that it finds all those. Now for the Git side of things, you're just going to git clone Intel's repository there. You're going to go into the directory it created, and then you're going to check out backport/main. It used to be that there was an Ubuntu specific fork, and now it's just backport/main, which is good. Like, they've merged that in a lot of things. There's a lot of suffering and pain that has been foisted upon the Intel team that this resolves, which is great. And I think that's a fairly recent development. And then from there, you're going to make, depending on how many processors you have, your i915 package. And the name of the package thing, the thing that you're making, is important. When that's done, that's going to build a Debian package one directory higher level outside of the Git repository, so ... basically. And you can apt install the driver package from there, the i915 out of kernel tree thingy. And in the output of that, it should show you that it's going through your installed kernel versions and building the module and doing the thing and blah, blah, blah. And hopefully that succeeds, and then you reboot and you look at dmessage output and XMU SMI and see if it seems reasonable. Hopefully it does. If not, engage on the forum. And then from there, you are ready to run the utility. You can run xpu-smi vgpu-c to create-n for the number of functions you want to create, 7 in this case on a Flex 140, and -d for device. If you only get the 1, it's going to be D0. But if you got more than 1, you can do 0, 1, 2, whatever. And it shows you when you use the XTU utility with discovery to show you the thing. It also shows you the PCIe addresses. And you'll see it then, if you go to the Proxmox GUI, you'll see it in the Proxmox GUI, which is great. Now, the systemd service. This is pretty cool. This doesn't I did this. This was me. Yeah, it's not great. I mean, it's okay. It gets the job done. Woo! So we've got XPU SMI at user bin that does all this stuff for us. So I've created a script that looks in Etsy for a configuration file for how you would like to configure your Flex device or devices. How many virtual functions you want to create or whatever. And so there's an example of creating that on the forum. You create the configuration file, and then you create the script file at user local sbin, and you can just paste the contents there. But what it does is, based on the configuration file, it will create how many virtual functions that you need, that you've asked it to. And you can look in the kernel message output to know how, like, you can't just create an infinite number. The card only supports a certain number. And I've noticed that the top number has fluctuated a little bit since the inception with Flex. Maybe that was pre-release drivers or firmware that I was using. But the more instances you have, the less VRAM each instance has. And generally, you don't want to get less than 512 megabytes per instance, IMHO. So do the math. And you can have it be a little bit more. It's fine. But based on the configuration that you say, so I'm creating 7 instances on a Flex 140, which is, I think, about as many as you'd want to do. I mean, maybe you could do 8, but really 7. And so that will create a bunch of instances in LSPCI. Hopefully I'm not telling you anything you don't already know from having worked on this or studied the screenshots very carefully. This script will do that, and it will notice the PCIe IDs that are created for each one of those, and it will bind the VFIO PCI driver to those. This sidesteps the bug in Proxmox. This is why I've been so verbose about explaining this, is because Proxmox doesn't grab those correctly. The kernel doesn't assign a driver to it either, but this will do that for you. And that is great. That's fantastic. So you can run this script, make sure that it works, make sure that it creates a number of functions. If it messes up, you can also run the XMU SMI to destroy the virtual functions as long as they're not in use, and try again, or you could try different parameters and configurations. But the next thing that we do, if the script is working correctly, is we create a systemd service to do that on boot so that it survives boot. So there's a systemd service that just runs and exits on boot, and it looks at the configuration file in Etsy and however you want it, and that runs at boot time so that Proxmox can then start or restart your VMs when the machine starts up. And so that's also in the guide, and that's pretty much it. That is pretty much all there is to do this. This kind of thing with systemd where you create a custom script to do thing, that should be in your toolbox anyway as a system administrator. I don't often think about like that as any kind of like wild or complicated, or is like, oh, look, it's so amazing. It's just dotting the I's and crossing the T's of computer janitoring. And that's pretty much it to get up and running. And then boom, here's our virtual machine running the Heaven benchmark at 115 FPS. Oh, did I say just one? No, there's actually like 18 machines running on our 32 core, 64 thread Zen 3 CPU here. It's 256 gigabytes of memory. I'm a little oversubscribed on the CPU side of things, but when the CPUs are not doing the graphics acceleration, this runs fine. Now, if you get one of these and it's got an ancient firmware, I'm so sorry. You're going to have to track down firmware for it. And that is why I appealed to the Intel people early in the video, because they're probably not still watching. Please upload the firmware, the actual firmware for the cards. So the firmware, there's like runtime firmware, and then there's like this other lower level firmware. And the lower level firmware on some of these Flex 140 GPUs entering the channel is like from the dawn of time. People are going to have a bad time with that. So I gave you the file name. It's Googleable. And you can install that on your GPU, and that's fine. And that one's actually still old, but it's not the oldest one. But it works, and it'll let you run stuff, and it's great. And so you can use XPU to update all your Flex 140 GPUs to that latest low-level firmware, which is a different firmware than the firmware that's in the Git repository from Intel and all that kind of stuff. At least as far as I know, if it is in the repository, it has a file name that I'm not expecting. Could be completely wrong about that. Look on the forum or for pinned comment or something. Yeah. So the other thing you can run into is sometimes the whole out of tree 915 thing where it's trying to load the in-kernel 915 and then you got the other one. You can actually kind of weaponize that dysfunction in the kernel because i915 will load from the initial RAM disk, but it'll load the wrong one. And it recognizes these are Intel GPUs, but it requires an override, that override, the hex code that we were talking about in the beginning, in order to attach to that. And when I say weaponize it, I mean you can just not do that, and then it's not part of the initial RAM disk, and so i915 loads, but then it doesn't bind to anything, so you can unload it later. So once the system is booted, you can modify my script to just unload i915, and then mod probe i915, and then you don't get the one that's in tree, you get the DKMS one, because initial RAM disk. And at that point, it's the correct i915, and everything works correctly. So if you get an error that's like error problem with sysfs or something like that, it's probably that. It's probably that you're actually loading the in-tree i915, because why do we do these things to ourselves? But again, community, forum, whatever. Thank you to our Patreon and Floatplane subscribers for helping make this kind of thing possible, because a lot of the time when I have to close the gap on these kinds of projects, I'm spending money. So thanks for subscribing. I'm Whittleless Level 1. If you have any questions, I missed anything, or you need stuff, let me know. All right, I'm signing out, and I'll see you in the forum.